Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 in November, so time zone 0, asking concepts relating to topic 9 as well, so that is electrolysis in the redox processes. Question number 32, let's see. So 3 cells with a platinum electrodes are connected in a series to a DC power supply. First of all, with a power supply, so the first impression that students should require to know is that this is going to be an electrolysis, because electrolysis is by applying energy supply or electrical energy to push some non-spontaneous redox to occur. So basically, this is going to be a non-spontaneous redox, as the electrode that you put is simply platinum, so which means an inert electrode. Whenever this is an inert electrode, nothing happens or just not participating to the reactions, but then they are just there to conduct the electricity. So that's why with the 3 beakers of electrolyte, what we are guessing is that the energy is now pushing down and force a non-spontaneous redox reaction to occur. So non-spontaneous simply means not automatically occur, right? Or not naturally occur. So that's why we try to push the electrical energy so as to drive this redox reaction to occur. Yeah, and so asking, what is the mole ratio of the product formed in each of the cathode? Right, the mole ratio. Yeah. So first of all, basically means that we are now only focusing on the negative electrode side. That means that negative electrode is going to be attracting the cation and do the corresponding reduction at the cathode, right? Yeah, and it is given that already to you that the products we no need to guess. That means on the beaker 1, maybe I'll just label it as beaker 1, beaker 2, and beaker 3. It is going to be the silver ion that attracted as the cation to the negative electrode, and so that's why you see silver, right? And on the beaker 2, you is observing that copper 2 plus is the one that goes to attract to be receiving the electrons at the cathode and do the reduction. And for beaker 3, that will be proton H plus from the sulfuric acid, that acting as the cation, right? So that's how we can guess that will be referring to Ag plus in beaker 1, copper 2 plus in beaker 2, and finally H plus in beaker 3. Otherwise, it doesn't make sense that we can see 3 of these products, right? So that's why obviously the first thing that they are not testing about is that they're not testing us on whether which ions wins or loss in terms of the preferentially discharged concept. But now already we know the 3 ions. But then what is going to be the linking between these 3 cells is that obviously you see they share the same power supply or within the same circuit, under the same circuit. If they're under the same circuit, here is the most important point that in background that you need to know is that if the cells are linked within the same circuit, they share the same number of charges to flow. In this case, the charge that flowing within the circuit, obviously one of them is going to be the electrons. So that means what I expect is that the number of electrons that flowing within the 3 circuits will then be the same. That makes sense, right? Because the current is going to be all the way through the 3 cells and together in the entire closed circuit. So that's why with this in mind, that means first of all we should be guessing or just deducing the 3 equations that regarding how the silver, copper, and proton that the hydrogen gas is formed from the corresponding reactant, which is the oxidizing agent, right? So that's why for silver ion we know that it will be receiving the electrons to become silver, and so copper 2 plus will then be receiving also electrons to form the copper metal, and finally the protons will then be receiving electrons to form the hydrogen gas. So this is the 3 equations that we should first illustrate and deduce. That makes sense, right? And with this perspective in mind, we know that under the same closed circuit, they share the same number of charges to flow, and this same number of charges here implies electrons. So that means for these 3 corresponding half equation within this entire closed circuit, they should be sharing the same number of electron flow as well. So that's why with this in mind, that means basically we should be balancing the equation based on their electrons, the coefficients of the electrons, right? So that's why here is saying, you can see 1 and 2 and 2. So the LCM, lowest common multiple, goes to 2. So that's why that means for the first equation, we need to multiply entirely 2 in order to make the 3 equations to be the same number of moles of electrons. So that will be matching with our meaning what's meant by the free cells under the same system of the same closed circuit, right? So with this perspective, when we put the 2 inside the silver, we will see entirely the mole ratio will then be silver becomes 2, going to copper just 1, and then finally of hydrogen also 1. So here we will be achieving to the mole ratio of 2 to 1 to 1 for this free balanced half equation relating to how these three products that is going to be formed, and the balance equation goes to 2 to 1 to 1. So that's why answer goes to B.